I'm Dr. Denise Hurd, Director of Research for the U.S. Poultry and Egg Association. Today, I'm delighted to be speaking with Dr. Ravi Kulkarni about one of his current research projects. Dr. Kulkarni is an assistant professor in the Department of Population Health and Pathobiology at North Carolina State University. Welcome, Dr. Kulkarni, and thank you for sharing your research with us today.
Thanks, Dennis. Thanks for having me. It's always a pleasure talking to you.
Thank you. Dr. Kulkarni, infectious laryngotracheitis is an economically important respiratory disease of chickens. Today, there are two types of commercial vaccines available for ILT, live attenuated and recombinant. The live attenuated vaccines may cause clinical illness, and the recombinant vaccines may not provide an adequate immune response. You recently started a project funded by US Poultry and its foundation titled Enhancing Immunogenicity and Protective Efficacy of Recombinant ILT Vaccines in Broiler Chickens. Can you tell us a little bit about this project and why there is a current need within the poultry industry for this type of research?
Sure, Dennis. First of all, I would like to thank the U.S. Poultry and Egg Association Foundation, for recognizing our project for funding. So, as you just, highlighted, infectious laryngotracheitis, it's a viral disease caused by alpha herpes virus, and it's highly contagious respiratory disease of chickens. Particularly, I can give a little bit of background, on the disease and the vaccines, and then build upon what's the need for the current research that we are going to talk about. So, in terms of the broilers, particularly in recent years, there have been increased incidences of this particular disease, leading to poor production, and there are mortalities associated with it, and also the condemnations. So by and large, like there have been like several strategies that have been adopted to control this disease, of which the vaccine-based control has been pretty effective so far. However, coming back to the vaccines, there are, as you mentioned, there are two types of commercially available vaccines: the live vaccines and the recombinant vaccines. So the live vaccines, which we call them live attenuated or modified live, either the CEO, which are from the chicken embryo origin, or the TCO, which are tissue culture origin vaccines, have been used. So the good thing about these live vaccines is that they are able to provide optimal immunity to ILT and reduce clinical disease as well as the mortalities. However, the major disadvantage with the live vaccines is that the vaccine virus can retain the virulence. Virulence is the capacity of the virus to produce the disease. So they can retain the virulence, and the virulence can get increased upon bird-to-bird passage. So which is not ideal, particularly in the broiler population in the endemic zone. So if there is virus spilling over, then it will hurt the susceptible flocks and they will come up with the clinical disease. So on the other hand, as you were just mentioning about the recombinant vaccines, there are advantages associated with these vaccines, such as they can reduce the clinical signs, they can improve the performance, and above all, they can be administered in ovo, which is for ease with the mass administration. However, again, with these vaccines, the recombinant vaccines, there are certain disadvantages. First and foremost is the inadequate immunity that you just highlighted. So inadequate is suboptimal level of immunity being induced by the recombinant vaccines as compared to the CEO or the live vaccines. The second disadvantage is also that there is delayed onset of immunity, which is not really ideal in broilers because, as you know, broilers are kept for a short period of time and you want a vaccine that can kick in early on. And the third disadvantage also is the cost. So considering these, particular disadvantages, I have to also mention here that some of the vaccine work and the virulence studies have been done here at NC State College of Veterinary Medicine by Dr. Jim Guy and Dr. Isabel Jimeno, who are the co-investigators on this project. And the current need is that the research question we asked was that how can we enhance the immunogenicity or the efficacy of these recombinant vaccines to a level where they can produce an immunity which is comparable to those induced by the live vaccines. So in order to do that, we have come up with a research idea to incorporate adjuvants which have been, tried and tested and then shown to be immunologically active in chickens that can be incorporated with these recombinant vaccines to enhance immunogenicity as well as also make them more effective in terms of providing the protective immunity against ILT. So I think that's as brief as I could.
You. Your approach sounds really novel. Has this approach been investigated before? And if so, can you share whether or not it was successful?
So that's a good question, Dennis. Our approach involves the use of certain, adjuvants. Adjuvants, I'm talking about the newer class of adjuvants called the TLR adjuvants. TLR stands for toll-like receptor adjuvants. And these receptors, just a little bit of background, these receptors are those expressed by the cells of our body, particularly the cells of the immune system, which are specialized in recognizing microbial agents, such as like bacteria, virus, or the fungi. So they have this ability to differentiate the host molecular patterns versus the pathogen-associated patterns. So why I'm telling this is that over the last 2 decades or so, people have used the molecules that can bind these receptors and being used as immunostimulatory molecules. For example, in chickens, our interest is in TLR21. TLR21 is a receptor that can recognize the microbe-associated DNA. So previously, in my previous appointments, I have worked with using these CpG molecules that have been shown to be immunostimulatory in chicken macrophages. There are quite a few people who have used certain ligands that can trigger the TLR when injected in chickens and then have been shown to be effective against E. coli, Salmonella, and also to some extent certain viruses such as avian influenza virus, and also to some extent the ILT virus. Now, our approach is such that, if you look at using these CpG DNA molecules that can trigger TLR21 in birds, if they can be incorporated into the recombinant, vectored vaccines, either the fowlpox vectored or the HVT vectored ILT vaccines, can we boost immunity against ILT? That's the approach which hasn't been well explored, or rather I should say well understood. So that's why we wanted to take this approach to incorporate the adjuvants into the recombinant viral vaccines and then test them into an experimental challenge model that we have it running here, particularly used by Dr. Guy and Dr. Jimeno, and then test the efficacy of the recombinant vaccines and also investigate immunological mechanisms of the protection. So that's an overview of the approach that we are trying to take using these adjuvant molecules, making sure that the adjuvant doses that we use in ovo administration are safe, and then identify appropriate doses and then use them as vaccine adjuvants.
What do you see as the overall impact of this study?
I think the overall industry value will arise from the findings that we are going to, yield from this particular project, as if we are able to use these, adjuvants to make the recombinant vaccines more efficacious, and which are able to, induce effective immune responses to protect against ILT virus, and induce an optimal immunity to a level of live vaccines, then the industry is going to get benefited, particularly using these recombinant vaccines, given in ovo. So in our project also, we are going to do the in ovo administration of these vaccines. And that way, I think it's going to get the industry benefited. And the other important aspect also is that, these are foulpox or the HVT vector vaccines. So this way, what happens is that not only ILT, but also we would anticipate that it will increase immune responses or the immune enhanciation as far as controlling the Marek's disease, which is the HVT vector, or the foulpox in case of the foulpox vector vaccine. So I'm looking at like twofold benefits to the industry coming out of our project, and or anticipating the results that we are going to see in the near future.
That's excellent. And I just want to thank you so much for sharing your work with us here today. And before we go, is there anything else that the industry should be excited to look forward to?
I think, Dennis, the industry should be excited to see more and more adjuvanted vaccine work coming from the College of Veterinary Medicine here. ILT is our focus at this point of time, and the other important thing that I anticipate that one of the advantages with these TLR adjuvants is they provide dose sparing effect. As we know that, some of the producers they tend to use fractions of the full doses of the vaccination because they are expensive. But what we are trying to look at is if using these adjuvants can reduce the dose. Say, for example, if you add an adjuvant to half of the full dose recommended, then you are able to achieve an optimal immunity. In that way, it will reduce the cost of vaccination. So I would expect that the industry can be looking forward to more and more research from our college here at NC State.
Thank you. As always, it is a pleasure to see you and speak with you. And we are excited about the work that you have going on. I know the industry, as well as myself, will be sitting on pins and needles to get the outcome of your research. So again, we appreciate you taking time out of your busy schedule to speak with us today.
Thanks, Dennis. Thanks to the US Poultry and Egg Association. It's really good to be working together.
Thank you.